equals to 1, 2, and 3. Similarly, second possible is n equals to 2. So that like that the transition is going to be takes place here from 2s to second level to the third level. How the transition is going to be takes place here. Next, most important essay question is vector atomic model. So in this vector atomic model, you need to know about the what is the spatial quantization. Okay. Next, the everywhere we have to be consider that what is the Bohr's postulate. According to that only, the orbits are which is to be quantized in magnitude, means the size and uh, the size value, and also here the quantum theory which insists on the quantization of orientation of the orbits in space or simply the direction. So for this purpose, the direction of the applied magnetic field applied to the atom here. Therefore, how the projection of the quantized orbits on the field direction, which is also to be quantized. So only such orientations which are to be permitted in the case of spatial quantization. The principle of the space quantization could not be explained. The splitting of the spectral lines. Why the spectral lines which is to be splitting here, it could not be explained in detail here under the application of magnetic as well as the electric field. Okay, magnetic field which is related to the Zeeman effect, electric field which is related to the Stark effect here. Okay, next one, spinning of electron. So Uhlenbeck, Goudsmith, you need to know about that. How, because of they have been explained the fine structure, okay, of the spinning electron, so that the electron spins about the axis of one. In addition to the orbital motion here, the quantum theory which insists of the quantization of the spin also. And here you need to know about the what is the quantum number, spinning quantum number, that is S, which is to be denoted here. Later on, the principal quantum number, you say that here small n, which shall be symbols in Bohr atomic model. The integer values is n equals to 1, 2, 3 like that. Next is the orbital quantum number, small l value. What is the integer value which includes the 0? That means here this is similar to that of the azimuthal quantum number n5 according to the Sommerfeld. If n equals to 3, what is the L values? Possible L values here 0, 1, 2. If L equals to 0, it represents the selection rules. If L equals to 1, represent the p electron. Okay, so that like that the values which is to be changing here. What is the total orbital angular momentum PL value equals to LH by 2 pi, LH cross LH by 2 pi, or else square root of the L into L plus 1 H by 2 pi. In some textbook, they have to be writing here H cross. H cross is nothing but H by 2 pi. What is spin quantum number? The spin quantum number, which is yes, this is also here you have to say that in place of L, simply you can write it down that S into S plus 1 H by 2 pi. The spin values are plus half to minus half. Next, total angular momentum L plus S, which is nothing but that is the J, Pj value that is to be giving out here. J value should be varying from here 3 by 2 to R 1 by 2, and S values are plus or minus 1 by 2. Okay. So that is the total angular momentum of this. So to explain the splitting of spectral lines, okay. So here we have to consider the number of quantum numbers and their array later on orbital quantum number ML value. Similarly, MS is also be there. So here the projection of the orbital quantum number L as well as the magnetic quantum field direction, which is to be known as here magnetic here orbital quantum number. So the values which should be varies from plus minus L to plus L, including 0 here. So you need to know about that. You have to draw this figure also. Next is the magnetic spin quantum number. ms values. So this is also varies from the values plus of to minus of. Okay. And next, magnetic total angular momentum, quantum number mj values. Okay, these are important here. So j values are l plus or minus s. Okay, s values plus f plus or minus of values. So that mj can have only odd of integral values. So we can have 2j plus 1 values that way, that is from the minus j to plus j including 0. So you need to know that, you need to draw this. Next, Frank hedge experiment. Okay. So what is Frank hedge experiment? According to the Bohr's, the atom will be in a ground state when the electron which is to be revolving from the first orbit, and if it is going to be radiating such energy, the electron from a ground state should be raised from the higher energy state by absorbing such energy. This process you can call it as a excitation. Okay. So when the excitation portion is to be reached here, the electron knocked out of the atom, then the process is known as ionization. So that means it is to be releasing again, which is come back into the ground state level. So here hydrogen atom, there is only one ionization potential, but it can have several excitation potentials. So in the case of atoms, more number of electrons, there can be more one ionization potential. And here the energy required to remove outermost electron, which is known as first ionization potential. Okay. So that what is the energy required to remove the electron from the second electron, which is also known as the, which is more attached to the nucleus here, which is known as the second ionization potential, which is greater than that of the first ionization potential. Okay. 1 minute. So helium has a two ionization potentials. One is at 24.5 electron volts and 78.6 electron volts. So these critical potential, which can be determined by the experiment, which was devised by the Frank and Hedge. Okay. So this is apparatus. Batteries are there. Varying battery. Coil is there. Okay. Filament is there. Targeting position is there. Ammeter is there. So you need to know and how the accelerating potentials, which is going to be varying with respect to the collector current here. Some fall is there, again, spontaneously it is to be increasing here. You need to observe that. That is the summary. Okay. So for the wavelength of atomic spectra, which is an empirical formula, V nu equals to 1 by lambda into RH is the Rydberg constant, 1 by NF square minus NI square. ఓకే, మీ ఎట్లా రాసినా పర్వాలేదండి. 1 by NF square minus NI square అని రాయొచ్చు, లేకపోతే ఇనీషియల్ మైనస్ ఫైనల్ అని రాయొచ్చు, ఎట్లా అయినా రాయొచ్చు. N2 అన్న N1 అని కూడా రాయొచ్చు. ఓకే, బట్ యూ నీడ్ టు నో దట్. సో దిస్ ends our first one. And what are the questions here? Following questions in detail. Main characteristics of line spectra, empirical laws. Bohr's theory, obtain the energy level of hydrogen atom. Next, vector atomic model, expected question. Okay, Randy? Right. So by tomorrow's class, we will discuss quantum numbers. Most important, we need to discuss about the quantum numbers. Right, all the best.